Bismillahirrahmanirrahim. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Right. This one is lecture 4, wide area wireless network, principle of cellular network. Right. So we begin with what is cellular network organization. As we understand, it uses multiple low power transmitter, which is 100 watt or less. Right. This is what called cellular network. Area is divided into cells. So each served by its own antenna. So if you look at the small cell in a certain what called city or in a city, there is an antenna. That antenna will serve for a particular cell and served by a base station. Later on, we will cover what is base station. Consisting of transmitter, receiver, and control unit. We have discussed one. This is an antenna, and there is a allocated frequency band, and core cells set up such that antenna of all neighbors are equidistant, meaning that they are between cells. They are equivalent in terms of distance in a hexagonal pattern. So we will see this one in the next slide. All right. So this is what we call equidistance. The D is basically, if you look at this one, this is like a cell, but actually in the real world, it's not like happen like this one. But this is to visualize. So it's easy for us to visualize. So the distance between the what called the node are equidistant. They are similar. So this is in a square pattern. This is in a hexagonal pattern. So the distance between I will call this one is one frequency, and this is one frequency. From one frequency to another frequency is equivalent. Okay. In a cellular network, there is what called frequency reuse. Adjacent cells assign different frequency to avoid interference or crosstalk. So if you look at this one, okay, if you look at this one, for example, this one cell, yeah. Let me get this one. Okay. This one cell, and this one, and also this one cell. If it is this frequency 1 and this is frequency 2, right? They are adjacent to get. This is frequency 1 adjacent to frequency 2, because they are different frequency, and they are not actually do the interference between themselves. Even over here, number 3. But if you put one over here, then this is what called an interference, because this is two same frequency but they are adjacent, right? Okay. So this means adjacent cells assign different frequency to avoid interference crosstalk or crosstalk. So objective is to reduce frequency in nearby cells. So the objective of having a frequency reuse, so that you can use the frequency in the other cell, so that you avoiding the limitation of frequency. But for example, if you don't reuse the frequency, you don't have the frequency reuse concept, then you end up with limited of frequency. So as we I discussed this one. So this one frequency 1 can be used somewhere over here. Okay, somewhere over here. This is the frequency 1. I can reuse that frequency, and this frequency is adjacent with maybe frequency number 7, and this is number 8 maybe. So they will not have the interference between them. Okay. So The issue is to determine how many cells must intervene between two cells using the same frequency. So this one will be answered, this one. So if you look at this one, this is we use n equal to 4, meaning that the size of cell. If you look at this one, 1, this is 1, 2, 2, 3, 4. This is the what called the pattern. And then look at the pattern over here, and look at the pattern. So you look at the frequency number 1. Okay, frequency number 1 is reuse over here. Frequency number 1 is reuse over here. Frequency number 1 is reuse over here. So look at the distance between them. They are not interference adjacent each other. Frequency number 3 is reuse over here. So this is what called reuse pattern, where the size of cell is n equal to 4. And you can increase this one, the size of n equal to 7, into that particular pattern. Right? So 1, 2, 3, 4, 5, 6, 7, and then also repeated this one. But to make sure, so that the adjacent, this is what called adjacent cell, will not having the same frequency. Why? This is to avoid the interference. This is what we call cell. This is cell, and each of the cell they have a antenna base station there, and receiving transmitting antenna. Right. So there is approaches to cope with increasing capacity. How to increase the capacity of particular cell? The first one is adding new channel. You can add new channel in that particular cell. Of course, that is will increase the capacity. Second is we can use frequency borrowing. Frequency are taken from adjacent cell by congested cell. So for example, if there is a two cell, for example, this cell 1 and this one is a cell 1, and this another one cell, and this is another one cell. So for example, this is busy, this is not busy. Okay, when this cell is busy, in order to cope with the increasing capacity, this cell can borrow the frequency from the other side, the other cell, which is n, a non-busy one. This is what we call frequency borrowing. Cell splitting. Cell is in areas of high usage can be split into smaller cell. So the cell that is in high frequency, for example, this one, we can split them into 2. Okay, so that easy to manage, and then you can provide, because if you have a wider coverage, for example, like this one, this area, okay, this area is wider, then the what called the speed or the serving this area will provide low frequency. So if you have congested, you want to maximize the optimize the usage of that particular cell. It's better to divide it into a small, then it's easy to manage. Or the other one is we use cell sectoring. Cells are divided into number of wedge-shaped sectors, each with their own set of the channel. So this one is different than splitting. Splitting is you split them, but cell sectoring is you just have their own different channel. So you shape them into different sector. Or you can do microcell, which is antenna move to, for example, from the antenna move to building to hills, and to lamppost. For example, if you look at the cell, which is the bigger cell, from the bigger one, you manage the smaller one and go to the smallest one. So this is what we call microcell. So microcell, you move from bigger to smaller. So you imagine in this cell, maybe in this particular area, you can have many cells, microcell. Okay. So it's easy for you to manage. This is what we call the approach to cope with increasing capacity. Yeah. That's 5. Adding new channel, frequency borrowing, cell splitting, cell sectoring, and microcell. So this is an example of cell splitting. You split the things, the cell into a smaller one, smaller one. So this is the bigger cell, and then you can see this one. You split them into a smaller one. Okay, this is the typical parameter for macro and micro cell. This one D90 in 1995. So if you look at this one, the micro, what's the cell radius? Bigger, 1 to 20 kilometers. So if you can imagine Kuching and Samarahan, for those one not in Sarawak, so the distance between, for example, Unimas to airport is about 20 kilometers. So that is what we call consider macro. You can have one antenna to cover, but of course the coverage, when it's the big coverage, you need more power, 1 to 10 watt. And look at the average delay. Even though it is a very small, 0 to 0.1 and 10 microsecond, but still we call it a delay. Still there is a delay which is higher. Maximum bit rate is 0.3 megabit per second. So that's why in a macro, the wider the coverage is, the lower the what we call bit rate. And look at the micro cell, because it's very small, it cover up to 0.1 to 1 kilometer. This is all like in one place. For example, 1 km is not that big. For example, it can cover one Unimas, for example. Even Unimas is quite big, so it can divide into micro cell. So the transmission power is 0.1 to 1 watt, very lower. And look at this, the difference is, this is microsecond, this is nanosecond, very very fast. So the smaller the delay is, the higher the transfer. So the bit rate is 1 megabit per second, is quite higher compared to 0.3. So this is the cellular system overview. So we have learned this one. This is what we call PSTN, right? Public switch telephone network, right? Public switch telephone network. This is a public telecommunication switch network, or PSTN they call it, public switch telephone network. This is landline, telephone landline, and connecting to the MTSO. MTSO is one of the controller. I would say this one is controller. In order to, as we learn this one, this is in digital, digital like this. Have a discrete number 10100, and in order to transform this one into analog, there must be MTSO controller. And also, not only that, in this lecture we'll learn how from the landline to connect to the mobile, which is moving, or car. So there is they call it, this is a base station. Base station is, as we mentioned in the cellular network in the previous slide, this is covering each of the base station, each of the cell. There is a base station, which is cover all the. This is like an antenna, or not an antenna. It's a base station, is more than an antenna. So they will be controlling one of the cell. So this is the component. Got a MTSO, mobile telecommunication switching office, and then you got base transceiver station, or they call it base station, BS. Right. This is an explanation of the component. Base station includes an antenna, a controller, and a number of receivers. So this is the base station. The component of the base station is antenna. There's a controller, Later on we will learn this one, and then number of receiver, which is the user lah. Mobile telecommunication switching office, or MTSO, connects calls between mobile unit. Okay? So this is the responsibility of mobile telecommunication switching office. Remember this, there is two types of a channel available between mobile unit and base station. Mobile unit is your mobile phone. So your mobile phone, this is base station. This is your mobile phone. Okay, so your mobile phone is always reporting to the base station. Okay? That's why you got the bar. Okay, like that. If you far from the base station, your communication bar is on maybe 1 or maybe 2, like that. Yeah. So there are two types of channel available between mobile unit and base station. This is what called control channel. Control channel is used to exchange information having to do with setting up and maintaining calls. What is that? Is, for example, if I want to call somebody, right? So the first things that I need to check is there any coverage near to my mobile phone? This is depending on the signal. So if there is available, then I will try to establish communication to the base station, and the base station will check my billing. Is there any you got the what called allocation for calling, or you got the bill what called credit in order to establish the communication to other party. If not, then they will not allow the connection. But if you have the credit, then they will setting up. So setting up is what we call under the control channel. After the control channel, once you establish the connection, and you have traffic channels. Traffic channels is carry voice or data connection between users. So if you remember in your datacom, this is what we call connection oriented. Connection oriented meaning that before you can transfer the data, you have to establish the communication, the line first between all parties that are involved. Whether it's a router, whether it's a base station, must be set up first. Once the things is agreed, everything can support the call, then you can transfer the data. So this is what called connection oriented. Right, this is step in MTSO, control call between mobile user. So mobile unit initialization, what it does, it scan and select the strongest setup control channel, use and monitor the channel. So mobile unit is, that's why I said is do the scanning, reporting to the base station. Cells with different frequency bands repeatedly broadcast on different setup channels. So this one is, if you are in frequency 1, they will send an echo, send a signal repeated or continuous for certain period of time, and handshake with the MTSO to identify the user and register its location. So this is the what called the function of mobile unit. That is the initialization path. And when the mobile start originated call, so first what happened is, if the mobile unit want to call the other party, first it check the setup channel is idle by examining the information in the forward channel from base station. So the mobile unit will monitor the channel. It is idle, If it is idle, then if idle is detected, the mobile may transmit on the reverse channel to BS, where the number of the call unit will be sent. So this is if it's idle. If it is busy, then of course that channel you can your user. Once it's free, then you can send the mobile unit can send data for the connectivity. Let's take an example. For example, in this one, in diagram A, this is what called DISCA, right? DISCA monitor the strongest signal, because DISCA can see the signal from this base station and this base station. From the diagram, you can see that this is the strongest one because it's near in the cell. So what happened is this car will be registered under this base station, right? So this car will request a connection to the will register all the current location to this base station, and the base station will register this one request for connection to the MTSO, right? Okay. When it comes to paging, if you for example, paging is you call someone in that particular area. For example, if you go to the supermarket, there will always be an announcement calling for supervisor 1, calling for supervisor 1. So that is what called paging. Yeah? To complete the call to call unit, MTSO sends a paging message to certain base station depending on the call mobile number. So paging, for example, if the MTSO receive a call, a request for call to particular mobile phone or for particular devices. Yeah? So of course MTSO, for example, doesn't know. Of course MTSO have all the record of the registered mobile. Yeah? But because this is on mobile, maybe that particular devices or mobile is not in that particular area. What the MTSO does is the MTSO will send paging message to certain base station. So depending on the mobile number, so they blast the message. So what happened? Each of the base station will transmit the paging signal on each own assigning setup channel. So they will transmit the paging signal and then see and see what are the what called the channel setup and what are the information that containing that particular channel. In a process of call accepted, and you can see this one. This is what we call paging. So when there is a call, the MTSO will blast all the particular all the message into that particular base station, and then the what called the responded base station, which is they got the number or the information about that particular that request the to establish the call, will reply to that particular MTSO saying that, hey, this guy is actually under me, so that the MTSO will direct the request into that particular base station and establish the communication between this car and this car, right? So this is what called the process of call accepted. I hope that one is clear. So if you can recap, so in this one, for example, this car is want to make a call to that particular car, but what happened is this car is moving, this also moving, and this car is associated. Later on we will see the handoff associated with this channel, and then reported to the MTSO request, and then the MTSO, if for example this car is want to communicate to that car, this car is request for connection to the MTSO, and the MTSO will do paging, because MTSO doesn't know, even though MTSO knows that in this area, but MTSO need to make sure that this car is still in the region of that particular cell. And once the confirmation from this base station that this car is in that within that cell, then they will try to establish the communication, right? Okay, on the ongoing call, while the connection is maintained, the two mobile units exchange the voice and data signal going through their respective base station and the MTSO. So this one is normal ongoing call. So the concept of handoff, if the mobile unit move out of the range of one cell into the range of another cell during the connection, the traffic channel has to change to one assigned to the base station in the new cell. It means that, for example, if this car is moving over here, imagine the car is already over here, right? The car is already over here. Move to this one. So no more the base station over here need to transfer all the information about this car into this particular base station. How? This is what we call a process of handoff. The base station will inform the MTSO that this car is no longer in the area of, if I can call it, this is A and this is B. Okay, channel area B. Okay, no more in the A, now it moving to. So the handoff is happening somewhere over here. Okay, later on we will learn this one later. Somewhere over here. Okay, so when the car is in that particular area, the handoff process occur to tell that this car is no more in the area of A. So this base station will give all the information to MTSO, so that MTSO can communicate to the base station B to handle the communication. So that is what we call handoff. Okay. So this is an example. This is an example. So if this car is moving over here, so this is the associated base station will be differ. This is what we call handoff process. Right. Call blocking. Okay, this is an additional function in the MTSO control call. During mobile initiated call stage, if all the traffic channel assigned to the nearest base station are busy, after the pre-configured number of repeated attempts, a busy tone is returned to the user. So this is what called, is a similar like telephone. For example, if you call your friend, actually not your friend in the previous one, maybe concept, when you call your friend maybe is somewhere else is available, but the problem is maybe the line or the base station is being used. For example, I can give you an example. If there is a disaster happen in that particular area, so if you want to establish connection to that particular area, you cannot, because automatically all the communication system are divert into emergency. So it's not that your friend you cannot call, but all the communication has been blocked. So this is what we call happen sometimes, but in telecommunication they try to avoid this one. Try to minimize call blocking, because it seems like it's not good for the what called the purpose of having the guarantee of communication. So if it is busy, meaning that it's not because of the phone, maybe because of the line is not available. So bear in mind that is called call blocking. This is who control that. This is MTSO. Call termination also. is one of the function in the MTSO. When either one of the user hang up, the MTSO is informed, and the traffic channel at both base station are released. So if one of your partner, when you establish a communication, for example, and then this is the communication, one of your partner is hang up, then all the communication also released by the MTSO. This is what called call termination. Another function in the MTSO is call drop. During call connection, if the base station cannot maintain the minimum requirement signal strength for a certain period of time, the traffic channel to the user is dropped and MTSO is informed. So this is also suddenly, for example, you heading towards no coverage, but you're still maintaining the communication. But if you go further from the base station, then the base station cannot handle the communication because there is a certain branch. We have learned this one, right? So when the base station cannot handle that particular connection, they will they will drop the connectivity and inform the MTSO. The other one is call to or from fixed and remote mobile subscriber. This one we have seen this one. Since MTSO connect to the PSTN or public switch telephone network, it can set up connection between mobile user in its area and a fixed subscriber. Fixed subscriber is the telephone line or they call it PSTN network. This one. MTSO can connect to a remote MTSO via telephone network or via dedicated line. Dedicated line is landline. So this one is straightforward. Okay. This is about mobile radio propagation effect. Signal strength. We have learned this one. Must be strong enough between base station and mobile unit to maintain signal quality at the receiver. If you remember, this is what called like SNR, signal to what called noise ratio, right? So the certain amount, certain quality of signal need to be maintained between the mobile unit and the base station. Must not be strong as to create too much co-channel interference with channels in other cell using the same frequency band. So this one, so if you look at the communication, as this one is adjusted by the base station, later on we will see, must not be so strong. Okay, why? If it is too strong, that will create a co-channel interference. Co-channel meaning that channel inside in a cell, in one cell there is a channel. Okay, so if this channel is too high, you might be interfere with other channel. This is what I call. So that you need to control. Fading signal propagation effect may disrupt the signal and cause error. So we have learned this one. Fading also one of the cause of the mobile propagation effect, mobile radio propagation. Okay, we come to the hand-off performance metric. So this is a metrics how to measure when to do the what called handoff. Cell blocking probability of new cell being blocked. So this is just a matrix. A matrix meaning that is to measure. If you want to measure the handoff, if you're talking about cell blocking probability, that is the probability of new cell call being blocked. Call dropping probability is probability that a call is terminated due to the handoff. This is metrics. Nothing. If you know metric is like something that we want to measure. We want to measure. For example, what is the call dropping probability? If they say is 0.1. So meaning that the probability that call is terminated due to hand off is very less. But if they say 1, then that is not good, yeah, because all the what called the call will be dropped upon the hand off process. Call completion probability that an admitted call is not dropped before it terminates. So this one is another matrix. Probability of unsuccessful handoff. This is probability that a handoff is executed while the reception conditions are inadequate. So these are all the metrics you can read by yourself. Okay. Another things that we discussed before is when actually when is the time that we need to do handoff crossing the when moving from one cell to another cell. Yeah. So this one is some of the what called indicator, or I would say approach taken to determine when to switch to other base station. For example, this one, you need to decide when you move over here, when is the time? Is it over here, or over here to do the handoff? Yeah? So this is the answer to that particular question. Okay, you can use relative signal strength. What is that? Handoff occurs when the signal strength is lower than the adjacent cell, which is handoff occur at point L1. So look at the diagram over here. So for example, this one, this car is moving from location A to location B. Okay, so this is from base station B, and this is base station A. So this is like, imagine this one. These two different area. This is what we call area B, and this is area A. So this car is moving this side, okay, toward this side. So when actually to do the switching from base station A to base station B. So according to the first rules, relative, if you use the relative signal strength, so the handoff occurs at point L1, where when the signal strength is lower than the adjacent signal. Okay? So basically the car is over here, the adjacent signal is this one. So when it occur at the point L1, so this is will be happen over here, somewhere else over here, when you use the relative approach, which is relative signal strength. But if using the second one, relative signal strength with threshold, as long as the signal strength is sufficient, then no handoff is necessary. Handoff will only occur at the predefined threshold, i.e. at level L2. Right? So you can refer to this one. So this is a certain threshold. Okay. So as long as not beyond this threshold, then even though over here no handoff is occurring. So when the car is reaching over here, still no handoff because still under the particular threshold. But when it's beyond the threshold, then they will do the handoff. Okay, so that is under relative signals strength with the threshold. And this is another one is relative signal strength with hysteresis. Okay, handoff occur if the new base station is sufficiently stronger by a margin h. This is what called hysteresis than the current base station. This is to prevent the ping pong effect. Ping pong meaning that you know when you play ping pong, the ball is you take this one, I take this one, you take this one. So it's still like ding dong. So hysteresis is one of the what called approach so that there's no ping pong effect. So this is hysteresis. This is the line one. We look at this one. So if the related signal with the hysteresis, so they will monitor this one. As long as this is the original signal, this is the original signal. As long as the original signal is okay, can handle the connectivity, then no handoff. But this is a minimum signal by the what we call base station, meaning that they can handle over here, so they can hand off at the L3. So that is the hysteresis. And the fourth one, relative signal strength with the hysteresis and threshold. They combine this one. The handoff will happen in the L4. And then this is another one is a prediction technique. Handoff decision based on the expected future value of the received signal strength. So this is not in the graph, not in the graph. They're using the what we call prediction. So this is if you use the hysteresis with the threshold. So this diagram is actually very useful in order to understand this handoff strategy used to determine the instance of handoff. So hopefully that is answering the what called the issue when handoff will be occur or take off during that particular from moving from one cell to another cell. Okay. This one is focusing on the power control. As we mentioned, the power control is sometimes is handled by the channel itself, by the base station, sorry, and also the mobile unit. Okay, we will see this one. Design issue making it desirable to include dynamic power control in a cellular system. Received power must be sufficiently above the background noise for effective communication. So we understand this one. So background noise is because, why background noise? Because we transmit in open A, open A. So meaning that we transmit the signal. Signal can be go to multi-path. So we have learned this one. Desirable to minimize power in the transmitted signal from the mobile. Why? We have discussed this one. Reduce the co-channel interference. Alleviate health concern and save battery power. So if you use minimum power, you can save the battery power. This one is still under discussion, but no problem. This one is still under discussion. Whether but there is in terms of health, it can cause cancer. But that's why if there is a big antenna, if it is only base station or relay, it's okay. But if it is power station, that's why they develop they do the power station away from the urban city, away from the village, because there is a what called concern about the health. The radio propagation or electromagnetic can affect to the health. But never mind, that one is of concern. In spread spectrum system using CDMA, it is desirable to equalize the received power level from all mobile unit at the base station. So this is actually we use this one in our daily life, in our mobile phone, CDMA. That's why if it is equalized, then it's okay lah. There's no co-channel interference. Type of power control. One is open loop power control. This is depends solely on the mobile unit. No feedback from base station. Not as accurate as closed loop, but can react quicker to fluctuation in signal strength. So open loop is meaning that is just try to remember, is solely on the mobile unit, meaning that the mobile unit is determined what is the power to communicate to the base station. This is your base station, and this is your mobile, and then this mobile is adjusting accordingly to the base station power. So they adjust if they are away, what is the kind of power. So, and this one is not accurate. Closed loop power control adjust signal strength in reverse channel based on the metrics of performance. We have discussed this one, metric performance, but that one is on the end of a lot of metrics in the from the base station. Base station makes power adjustment decision and communicates to mobile on control channel. So actually your mobile phone, this is what happened in our mobile communication, where the base station is instructing our mobile phone to adjust the power according to the what is the desired by the base station. This is what called closed loop. Okay? So we have two. One is open loop and the other one is closed loop. Okay, this is a GSM transmitter class for closed loop power. So for power class 1, base station power is 322 watt and mobile station power watt is 20. So this is sort of just for your reference. Okay, a bit on traffic engineering. Ideally, available channel would equal number of subscribers active at one time. So this is the ideal situation, but actually anything that ideal is very hard to achieve. But ideally, we want to have so that every time you call, you got the what called the channel, then you can communicate. In practice, not feasible to have capacity handle all possible load. Okay? So for n simultaneous user capacity and L subscriber, this is a concept. If L is representing the subscriber, N is representing the simultaneous user, meaning that the user at at the same time. If L less than N, this is what called non-blocking system. Of course lah, because you estimate like for example, this is the area, right? And then the number of subscriber is only like this. Of course, you can tackle lah, no problem, because you still got a lot of things. Okay? But if the number of user subscriber is greater than n simultaneous user, then you need to apply blocking system. That's why, like for example, this is the area, the user, the what called the system can afford, but you have a number of users is bigger like this. So you have to implement the blocking system. Okay, I guess this one we will after this slide we will continue to another, and this one will be considered a cellular lecture. This is lecture 4 and the other one is lecture 5 now. Blocking system performance question. Probability that call request is blocked. This is if you want to do the blocking system for this one. Then if your system is under here, meaning that your user is greater than your the subscriber is greater than your capacity at the same time, then you have to ask this question before you develop the system. The probability that call request is blocked, what capacity is needed to achieve certain upper bound on probability blocking, what is the average delay, what is the capacity is needed to achieve a certain average delay. This is, you need to ask this question and many more. This is an example question, so that when you develop the system, it will really serve the blocking system. Otherwise, your system is not good. Okay, so this one, the evolution of mobile system, I will deliver in the next lecture, lecture 5, right? So we'll discuss this one online. So I guess that, thank you very much. Hopefully if you don't understand, you can always email me, and then we can discuss later. Okay, thank you.